Welcome back everyone. So in this video basically we are going to talk about the example of finding root of this function of f of x is equal to x cube minus 3 with the help of bisection method. So idea is that first we will need to find out that bracket in which the root will lie, and the bracket will be found on the basis of the function sign. So when the function changes its sign, that means within that interval or within the two nodes where the function is changing its sign, uh, within that range only the solution will exist. So basically the function has to cross the zero line, f of x is equal to 0 line, within that interval. So to find out the bracket, we basically need to take the range of x. So we have assumed that x is equal to 1, 2 and 3 and 4, and then we have tried to calculate the value of this function f of x, uh, that is minus 4, 3, 22 and 59. So as we can see that at x is equal to 1 the function value is minus 4, and at x is equal to 2 the function value is 3. That means our root will lie within this range 1 and 2. So now we have done the bracketing part. So the first guess for the iteration 1 is x lower is 1, x upper is 2. And if we are finding the root with the help of this bisection method, then we need to take the average of these two, x lower and x upper. So it is 1.5. Now we have to find out the value of function at xl, x upper and x mid. So it is minus 4, 3 and minus 2. So the idea is that whenever this f of xl or f of xu, so basically we will compare the sign of this f of xr with f of xl and f of xu. So the value of x, so basically the value of either xl and xu will be replaced with this xr based on this sign of this function. So suppose if the sign of function at this midpoint, that is f of xr, is similar to xl, then this xr will replace the xl, and if the sign of this fr is similar to the xu, then this will replace the xu. So in this case, since the sign of f of xl and f of xr is same, that means the xr will replace xl. So for the second iteration, the xl is 1.5 while the xu remains same. Now if we take the average of these two in the second iteration, then that comes out as 1.75, and if we evaluate the value of this function at xl, xu and xr, then if we see that the function value at x, the function, the sign of the function value at xr is similar to the sign of the function value at xu. So basically the xr will replace xu and xl will remain intact. So xl comes out as 1.5 only, and the xr value replaces with 1.75. So similarly, if we take the bisection of this again, then it comes out as 1.625, and if we evaluate the function value at xl, xu and xr, then we can see that the sign of this function value at x midpoint, that is xr, is similar to the xl. So basically the x mid will replace the xl. So we have replaced the x mid with xl for the fourth iteration, and the xu remains intact. So in this way, basically we are performing the iterations until the function value at xr approaches 0. So as we can see that for x is equal to 1.7099762, the function value approaches as 10 to 1.3 into 10 to the power minus 4, and that is very close to equal to 1. So these are basically the iterative methods. So finding exact solution will be difficult. We will basically approach the exact solution in this way. Now if we the two way of terminating these iterations is either we look at the value of this function at x mid. So if it approaches 0, then we can say that this is my root, this x mid is my root. If it becomes 0 only, then definitely the x mid will be root. Another way of terminating the computation is based on the error. So error is calculated as the new value of xr minus the old value of xr. So for the first iteration, the error cannot be defined since there is no old value. But for the second iteration, we have the new value as 1.75 while the old value of xr was 1.5. So we can basically subtract and see that the error is 0.25. And we can take the absolute of this error, or we can basically we should take the absolute of this error. So positive sign will only come into the picture. This negative sign will not come into the picture. And for the third iteration, the new value is 1.75 while the old value was so the new value is 1.625 while the old value was 1.75. So the error will be mod of this 0.125. Similarly, we can compute the error and we can decide a criteria that if my error goes below certain 10 to the power minus 5 or 10 to the power minus 6, at that particular point, basically I will terminate the calculation and the XR at that iteration will be my root. So the point to remember is that first we will find out the bracket and then we will use the bisection method, and basically XL and XL, for the XL, either XL or XU will be replaced by the value of XR, that is the average of XL and XU based on the sign of f of XR. If the sign of f of XR is similar to the sign of f of XL, then XL will be replaced, and if the sign of XR is similar to the XU, then XU will be replaced in the new iteration. So that is how the computation of this method is done. So this is the way we can find out the roots of a function by using this bisection method. Thank you.